Let's solve a couple more linear equations. This problem says the Fahrenheit to Celsius conversion formula is C equals 5/9 times the quantity F minus 32, where C stands for Celsius and F stands for Fahrenheit. Solve this equation if, and problem A here says C equals 32. So my first step was substitute the 32 in for the C, and that gives me 32 equals 5/9 times the quantity F minus 32. Now we could solve this by getting rid of the fractions first by multiplying by the common denominator, which is 9. So I put a 9 outside of this whole thing. 9 times 32 is 288. 9 goes into 9 one time, and 1 times 5 is 5. And that 5 I'll distribute it through the F minus 32 in the next step. So let's distribute that through, and I get 5F, and 5 times the minus 32 is a negative 160. Now I'll get all my numbers on the left-hand side since my variable is on the right-hand side of the equation. So adding 160 to both sides, I get 448 equals 5F. And then dividing through by 5, I get that F equals 89.6. So in other words, 32 degrees Celsius is equal to 89.6 degrees Fahrenheit. Now we could have solved the same problem by multiplying by the reciprocal. So here's the exact same problem. The 32 equals 5/9 times F minus 32. Now this 5/9 is times this whole side. It's multiplied times the entire F minus 32. So I can get rid of the 5/9 by multiplying by the reciprocal. The reciprocal of 5/9 is 9/5. And then if I do that on this side of the equation, I have to do that on the other side of the equation. Well, 9/5 times 32 is 57.6. And the 9/5 cancels out with the 5/9. The 5 over 5 divide to 1, and the 9 over 9 divide to 1, just give me F minus 32. Now just add the 32, and I get 89.6. So multiplying by the reciprocal is a quick method to solve some problems. Let's go on to the next problem here. This problem says solve W equals negative 2/9 P plus 5 for P if W equals 10. So we're going to put the 10 in for W, and I have this solved several ways. Here's multiplying by the common denominator. We get 10 equals negative 2/9 P plus 5 right there. Now, multiplying by the common denominator, which is 9, well, I put all this in brackets and I multiply by 9. 9 times 10 is 90. 9 goes into 9 one time. 1 times negative 2 is negative 2, and that would be negative 2p. Whether the p is in the middle or on the numerator, it's the same thing. So this is minus 2p. Again, 9 goes into 9 one time. 1 times minus 2 is minus 2p, minus 2p. And then the 9 times the 5 is 45. Now what I did here was add 2p to both sides and subtract 90 from both sides. I put the 2p over here and made it positive, and subtracting the 90 puts a minus 90 on this side. Well, 45 minus 90 is a minus 45, and then finally divide through by 2, and you get negative 45 over 2, or negative 22.5. Now another method of solving this is you could have subtracted the 5 first. So subtract 5 from both sides and get 5 equals negative 2/9 P. Now the 5 is the same as 5 over 1, and now we got a fraction equals a fraction, and anytime you have that, you could cross multiply. So 5 times 9 is 45 equals 1 times negative 2p is negative 2p. Then just divide both sides by the negative 2, and I get the same answer I had before. Another way of solving this is to multiply by the reciprocal, but note that you cannot multiply by the reciprocal right off the bat because this negative 2/9 is only times the p. If the p plus 5 would have been in parentheses, I could have multiplied by the reciprocal right off the bat. But since it's not, first thing is subtract off the 5. And I get 5 equals negative 2/9 P. Now I'm going to multiply by the reciprocal on both sides. And the reciprocal of negative 2/9 is negative 9/2. So I multiply the 5 by negative 9/2. And I multiply this side by negative 9/2. Well, negative 9/2 times 5 is the same as negative 45/2, which is the same as negative 22.5, which is the right answer. And that's all there is to it, because on the other side, the two negatives make a positive, the 9s cancel out, and the 2s cancel out, and you just get P. So that is a pretty fast way of doing that problem. Let's move on to the next problem. On this problem, it says the winning times for the Indy 500 can be modeled or predicted by the linear equation W equals negative 2.3t plus 321, where W is the winning time and T is the number of years since the inception of the race in 1920. In other words, this means that T equals 0 is the year 1920. Okay, so you'll see that occasionally on problems like a starting date. So T equals 0 is the year 1920. It says complete the table for the linear relationship between the winning times and the year the race was won. So here's the equation, and it's giving you the winning time for each of these values here. So let's do one of these problems. Let's put the 350, that's the winning time, in for W, and we'll get what year it is. So put 350 in for W, and I did that right here. 350 equals negative 2.3t plus 321. Now solve this. So what I did was add 2.3 to both sides and subtract the 350. That moves the minus 2.3 to the left, making it positive, and then I move my numbers to the right, subtract off the 350. So at this point, the 321 minus 350 is negative 29, and I have 2.3t equals negative 29. So divide both sides by the 2.3, and if I do that, I get negative 12.61 approximately to the nearest hundredth. So now what year would that be? Well, t equals 0 was 1920. So here we're getting negative 12.61, and this would mean 12.61 years before, since it's negative, before 1920, the winning time would be 350. Well, what is 12.61 years before 1920? The year 1907.39. So if you wanted to say to the nearest year, it would be the year 1907. The winning time is predicted by this linear model to be 350 minutes. And if this would have been a positive, then we would have just added it on. For example, if we would have done this problem here where we're trying to find out what year the winning time is 200, well, we would have typed in the 200 or substituted in the 200 in for the W right there, taking the negative 2.3t to the other side, making it 2.3t, and subtracting the 200. So let me subtract the 200 right here. And if you subtract the 200 from 321, you get 121. You still have to divide by the 2.3, so it would be 121 divided by the 2.3. And if you do 121 divided by 2.3, you get 52.61. So let me put that here. 52.61, that's rounded to the nearest hundredth. So that means 52.61 years after. Now, because it's a positive answer here, so that means, again, 52.61 years after 1920, the winning time would be approximately 200 minutes. And that's by using this model. So 52.61 years after 1920 would be the year 1972.21. Now this one here, all you have to do to solve what is the winning time for the year 1950 is this. Well, 1950 is 30 years after the base year of 1920. So we would have to substitute 30 in for the t, and then at that point there's no equation to solve. You would just do negative 2.3 times the 30, and the 30 again came from the fact that you're taking how many years after 1920 is the year 1950. Well, that's 30 years later, so substituting the 30 in there for t, it's negative 2.3 times 30, then plus the 321, and if you work that out, you get 252. So the approximate winning time for the year 1950 is 252 minutes. And we'll stop it there.